Hello and welcome students. We are continuing the previous topic and discussing case number 4 where both the inputs j and k are equal to 1 considering the present state equal to 0 and enable input equal to 1. J equal to 1 enable input is connected common to gate number 1 and 2 with 1. Now since Qn is equal to 0, this is connected as a feedback to the input of gate number 2 and Qn bar will be equal to 1 since both the outputs have to be in complement to each other. This is connected to one input of gate number 1. As per the truth table of NAND gate, if any input is equal to 0, the output will be high. Since all the three 1 are there, the output will be low here. Now one input high, one input low. If any of the input is low, we know the output will be high, which means Qn plus 1 will be equal to 1. This one is connected as input to gate number 4. As per the truth table of NAND gate, 1 into 1 bar will be equal to 0. So Qn plus 1 bar is equal to 0. Now this says that the next state is complementary of the present state. Under this situation we say that a flip-flop toggles. Toggles means it is always changing the state to complement. If my Qn is equal to 0, my next state will be equal to 1. If my present state is equal to 1, my next state will be equal to 0. Whenever this situation occurs, we say that the flip-flop enters into the race around condition, and this occurs only when j is equal to k equal to 1, and this is the equation that the next state is always complementary to the present state. So when I have to write down this truth table, j is equal to k equal to 1, what will be the next state? Complementary of the present state, that is this will be equal to 1 here, this will be 0. Next, j is equal to 1, k equal to 1. The next state will be complementary of the present state. So this is the output and the truth table of JK flip-flop.